Komali Mam. In this video, I am going to teach you exemplar questions from solid state chapter. Let's begin the session. Let's see the exemplar questions. The first question from solid state is, see, this video I'm making, exemplar questions. It should be like if you have any exam, you want to revise in a short duration, that time this video helps you a lot. Let us see in short, fatafat fast, I'll complete these questions. Then you, before your exam, you can revise it. Which of the following conditions favors the existence of a substance in the solid state? See, when a substance exists as a solid, students, this is one particle, one atom. When the force of attraction between the atoms are strong, they have a strong cohesive forces, then it exists as a solid. If you heat, when they have a strong force of attraction, they have low thermal energy, low movement, and high cohesive forces, high force of attraction. And if you increase the temperature, if you heat it, then the particles start moving away from each other, then solid converts into a liquid. So I want to tell you that low temperature is favorable but not high temperature. If you keep a high temperature, solid converts into a liquid. Then in this question, low temperature is a favorable condition for the existence of a solid. Let's see the next question. Which of the following is not a characteristic of a crystalline solid? What do you mean by crystalline solid? Crystalline solid is the one where a regular pattern of arrangement you can observe. Suppose if you see a particle, same particle you can observe throughout the crystal, same particle arrangement you can observe. But whereas if you see an amorphous type of solid, the arrangement of particles is a short range. They're not present entirely the same. You can see here they're asking which is not a characteristic. There are true solids, correct, a regular periodically repeated pattern of arrangement throughout the crystal, correct, and they have definite properties like a refractive index. They have certain heat of fusion, they have certain melting and boiling points, correct, and these are having different properties in a different directions. Crystalline solids have different properties in different direction. We call that nature as an anisotropic in nature. What is the nature? Anisotropic. So this is they give an isotropic. This is the wrong statement. Let's see the next question. Which of the following is a amorphous solid? These are the examples for quartz is an example, quartz glass is an example, means amorphous SiO2. Quartz glass means amorphous SiO2. Only quartz means crystalline SiO2. So this is an amorphous solid. Graphite, chrome alum, and silicon carbide, these are crystalline. These are crystalline solids. Crystalline solids. And let's see the next question. Which of the following arrangement shows schematic alignment of magnetic moments of antiferromagnetic substances? What are these antiferromagnetic substances? See, in a solid, metal atoms are present. These metal atoms are grouped, these metal ions are grouped together. They grouped, see, this is metal ion, this is metal, all metal ions are grouped together into a domain. These metal ions are having what? These are having electrons. Each electron in this, see, all these are the metal ions, okay, together we call it as a domain. Each metal ion contains electron. That electron acts as a tiny magnet. When you keep these particular domains, all domains of a solid, I mean in an external magnetic field, then domains alignment will be one in clockwise, one in anti-clockwise, up down, this type of equal arrangement of top down alignment, we call it as an what? Anti-ferromagnetic. If all are in the same direction, then it is ferromagnetic. If unequal number, then ferrimagnetic substances we say. The next question is, Which of the following is true about the value of refractive index of a quartz glass? See, quartz glass is an example of amorphous solid. In case of amorphous solid, they're isotropic in nature, which means that they have same properties throughout the crystal. You know, in any direction, if you see, they have refractive index same, electrical conductivity same. These properties are same in a different directions. So, first option is the correct answer. Now see the next one. Which of the following statement is not true about amorphous solid? What are amorphous solids? Amorphous solids, on heating or a cooling, amorphous solids converts into crystalline solids. Yes, on heating they may become crystalline. They may become crystalline on keeping after long time. Yes, because when we are doing heating or a cooling, what happen, these crystals rearrange themselves in an, in an ordered arrangement. Then we get a crystalline solids. Amorphous solids can be molded by heating, correct? And their anisot, no, just now I told you amorphous solids are isotropic in nature. Isotropic means they have similar properties in all the directions. Now see the next question. The sharp melting point of crystalline solids is due to, see, max of questions are like difference between crystalline solids and amorphous solids. Sharp melting points are because of their arrangement. In a crystalline solids, the particles are arranged, regularly, same repeated pattern of arrangement we observe. A regular arrangement of constant particles over a long range order of, we observe. If it is a short range in the sense, up to certain extent it is different. Again, another direction it is different arrangement, then we call it as an amorphous solid. If all the particles are arranged, in a same, in all the directions, suppose, same kind of pattern it is having, a regular pattern if it is having, then we call it as an crystalline solids. So option B is the correct answer. What is the correct answer? Option B is the correct answer. Option B is the correct answer. This is your correct answer. Okay. Now let's see the question number 8. Iodine molecules are held in the crystal lattice by. What is this iodine molecule? I2 is an iodine molecule. I2. This is another I2. Iodine is a non-polar. This is one iodine is in a bond, covalent bond with another iodine. Then this is a non-polar, and this is also non-polar. Between these two non-polar molecules, the force of attractions are weak. These forces are called London forces. London forces. Option A is the correct answer. Ninth question. Which of the following solids is a network solid? Network solid means which is also known as a covalent solid. If you observe here, iodine is an, molecular solid. Molecular solid. This is an water also molecular solid. Solid SO2 is a molecular solid. Diamond is an covalent. Covalent, which is also known as network solid. What is this solid? Covalent solid or net. What do you mean by this covalent or network? Here if you see a diamond structure, each carbon is surrounded by 4. Again, each carbon is surrounded by 4. This type of, network structure it is having. Option C is the correct answer. Next question. Which of the following solids is not an electrical conductor? What is this? Which of the following is not an electrical conductor? They have given us 4 options. I mean, magnesium, titanium oxide. See, magnesium is a metal and titanium oxide is a metal. These two are good conductors, good electrical conductor. But whereas an iodine is a non-polar molecule and this is an, non-conductor. Whereas a water also in a solid state, it is not a good conductor. Both C and D are not a good conductors. Question number 11. before going to teach you question number 11, I want to give you a small trick box. Just open your pen and paper, take out your paper and just write these points. Otherwise, if you are directly, using your exemplar textbook only, just, you write in your exemplar textbook only, students. TiO, CrO2, ReO3, these oxides are metallic, and MnO, FeO2, and CuO, these are insulators. VO, VO2, VO3, TiO3, they are actually metallic, but they can convert, it depends on a temperature. If you change your temperature, they converts to insulator, and even if you change the temperature, they converts to metallic. Like that we can change it. So why I'm telling you this, because you need to remember this, because you can't tell whether they are insulators or conductors or in metallic, or they change. You can't say by seeing the examples. Now see the question, you will understand. Which of the following is not the characteristic of a ionic solids? Let's see that. The question, not this question, the trick box, another question. I changed it. I will give you the question based on the trick box. Very low values of electrical conductivity in the molten state? No, because ionic solids have very high electrical conductivity in a molten state, because in a molten state the ions are just free, so they move and they show high conductivity. That's why first statement is the wrong answer. And ionic compounds are brittle in nature, they have strong forces of attractions and interactions, and they are anisotropic in nature. All are correct. Option 1 is wrong, because they have given low value of electrical conductivity. No, they have high value of electrical conductivity. Graphite is a good conductor of electricity due to the presence of what? You know this question from 10th standard you were studying. Due to the presence of what? Free valence electrons. Because if you see carbon valence in a graphite, carbon 2s2 2p2, two electrons are present in a s and two electrons are present in a p. One of the electron jumps from s into p before hybridization. Then this s and one electron in s and two electrons in a p, they involves in sp2 hybridization. I know this electron is free. This is just like a revision I'm teaching you, okay, before just an exam is there, or you are giving 1 month of your exam or 2 months, just you want a revision for exemplar. That's why I'm making it in a series in exemplar questions. This electron is responsive, this is a free electron which is responsible for conductivity. So option B is the correct answer. Got it? Now see the next question, question number 13. Which of the following oxides shows electrical properties like a metals? The trick box I have given you, right? That is actually should keep this before, TiO, SiO2, MgO, TiO3. In this, which one shows the electrical properties? What is the answer? TiO shows the electrical properties as per the trick box I have given you over there. Which of the following, oxide shows the electrical properties like, one second. Yes. Which of the following shows the electrical properties like metals? This is SiO2. SiO2. This is SiO2. Okay. And as per the box, which one? CrO2. This is it shows that this metal oxide shows, what it shows? It shows the electrical properties. It shows the electrical property. Important. The trick box is important. Why in a few cases they acts like insulators? Why in few cases they acts like an conductors, metallic conductors? Because when the gap between a conduction band and the valence band is high, then they acts like an insulator. Or if there is no gap between them, they acts like an good conductors. If there is somewhat okay, then if you change the temperature, they will change. I mean, if you give the heat, electrons jumps from ground state to valence conduction band to valence band, and further takes place. The lattice site in a pure crystal cannot be occupied by. See, lattice site in a pure crystal, if suppose this is a crystal, all here a plus b minus, a plus b minus, all are present, and this is a kind of arrangement it is having. When an electron can when here molecules can occupy, ions can occupy, atoms can occupy, but an electron can occupy only when there is a vacant site. If a b if it is there, it cannot occupy, it cannot come and occupy over here. Here b, right? Yes. See here a plus, I am writing here electron. When this electron can come and occupy, it cannot occupy, it can occupy only when the vacant space is present. But vacant space present only when the crystal is impure. In a pure crystal, no vacant space. So the answer is electrons cannot occupy. Electrons cannot occupy. Option C is the correct answer. Graphite cannot be classified as. Graphite is a good conductor. Graphite is a covalent solid. Graphite is an network solid. Graphite is not an ionic solid. So graphite cannot be classified as an ionic solid. We can't break graphite as an ions. Cations are present in the interstitial sites in. What do you mean by interstitial? Interstitial means empty spaces which are present. For example, you see this is a plus, this is b minus, a plus, b minus, b minus, a plus, b minus, a plus. Like this, all these ions are present. Okay. And now, this is one kind of crystal. Are you following, students? This is a kind of crystal. Now, if one of the ion, like an A plus, which is moving from this place and it is coming and occupying over the empty space present here. The whatever the A plus is there, it comes and occupy this place. This type of defect, we call it as Frenkel defect. One of the constituent particle come and occupy interstitial site. We call that defect as a Frenkel defect. Now let us see what is a Schottky defect. A Schottky defect is observed in a crystals where equal number of cations and anions are missing from the lattice sites is a correct answer. If you see the same diagram, without drawing again, I'll teach you in the same diagram. See here, if this this is the case, right? One second. Same diagram I'll show you. Same diagram. Okay. Now, if this A plus is missed and B minus is also missed, then here empty spaces are just left to maintain that electrical neutrality, to maintain that stoichiometric ratio. Then these type of defects, we call it as a Schottky defect. What do you mean by Schottky defect? Equal number of cations and anions are missing from their lattice sites. We call it as Schottky defect. See the next question. Which of the following is true about charge acquired by p-type semiconductors? What is the meaning of p-type? See, semiconductors we studied two: n-type semiconductors, p-type semiconductors. What are these? How it will happen? Suppose, see, silicon is present. This is a silicon, which is a semiconductor. Silicon, silicon, silicon. What I am going to do, just observe carefully. Instead of silicon, the silicon place I remove and I keep a boron family element like boron, aluminum, gallium. So gallium I keep here. Gallium I'm keeping here. Instead of silicon, I'm keeping a gallium. When I keep a gallium, gallium is having only 3 electrons to share. But there is a silicon has a 4 bonds, but gallium is not having any other electron more than 3. So this bond gallium cannot form. Here another silicon will be there. Okay, this silicon will be there.
it is there. But gallium is having only three. This is called as a hole. This where there is no bond, that is called as a hole. This hole is responsible for conductivity. So p type semiconductors, the conductivity is because because of the hole. That hole is not having any positive or any negative charge. And now let's see about the n-type semiconductors. To get an n-type semiconductor from a silicon, it should be doped with a substance with a valency. What happens is, if you dope this silicon with n-type semiconductor, see how I'm doing. Silicon forms 4 bonds. Are you following? So very see, NCRT exemplars are like, you need to revise it. It is important. NCRT exemplar questions are important. I'm making a series on this. Almost all the chapters I'm trying to cover it. What you do is, make out a leisure time every day, just 10 minutes video, 15 minutes video. Simply if you sit and watch, just directly you can understand it. See, silicon place, what I'm doing, I'm doping with an other element, higher group element. What is that higher group element? Can be that higher group element I'm going to dope with nitrogen family. For example, higher group, nitrogen, phosphorus, arsenic. Yes, arsenic I keep. Arsenic is having 5 electrons in a valence shell. When it is having a 5 electrons, silicon is forming actually 4 bonds, 1 2 3 4. But arsenic is having 5 electrons, 1 electron extra. This electron is responsible for conductivity. This electron is responsible for conductivity. Here the conductivity is because of a negative charge. That's why it is called as a n-type. These are called n-type semiconductors, whereas a p-type holes are responsible for the conductivity. So how these n-type semiconductors are generated? When we are doping these group elements with a higher group element, like a nitrogen family, which is also known as a 50A group elements, or or a 15th group elements. They have 5 electrons in the valence shell. Option D is the correct answer. They have 5 electrons in the valence shell. And in a next session, I will give you the other questions from the remaining exemplar questions from solid state chapter. My name is Komali. I'm your chemistry mentor.
These are the questions from solid state chapter. Thank you so much for watching this video.